ਹੈਲੋ ਸਟੂਡੈਂਟਸ, ਹਾਊ ਆਰ ਯੂ? ਰਿਵੀਜ਼ਨ ਦੀ ਅਗਲੀ ਕੜੀ ਦੇ ਵਿੱਚ ਆਪਾਂ ਕਰਨ ਜਾ ਰਹੇ ਹਾਂ ਚੈਪਟਰ 2 ਐਸਿਡਸ ਬੇਸਿਸ ਐਂਡ ਸਾਲਟਸ ਦੀ ਰਿਵੀਜ਼ਨ ਇਨ ਜਸਟ 15 ਮਿੰਟਸ। ਸੋ ਲੈਟਸ ਗੈਟ ਸਟਾਰਟਡ। ਸੋ ਸਭ ਤੋਂ ਪਹਿਲਾਂ ਟੌਪਿਕ ਐਸਿਡਸ। ਐਸਿਡਸ ਕੀ ਹੁੰਦੇ ਨੇ? ਐਸਿਡਸ ਆਰ ਸੱਚ ਕੈਮੀਕਲ ਕੰਪਾਊਂਡਸ which when dissolved in water donate H plus ions and the corresponding anions. For example, a reaction is written here. HCl when dissolved in water gives hydronium ions and chlorine anions. Examples of acids: HCl यानी hydrochloric acid and H2SO4 sulfuric acid. Acids, the normal pH value, it is always less than 7. Acids are sour in taste. Last property of acids is that they are corrosive in nature. Now let us discuss the properties of bases. First of all, bases are bitter in taste. They are soapy to touch. And the third property is they give OH minus ions in aqueous solutions. Next, we are going to discuss about strong and weak acids and bases. Any acid is a strong acid when it has a capacity to give more hydrogen ions in water. And any base can be a strong base when it gives more quantity of OH negative ions in water. Examples of strong acids are hydrochloric acid and sulfuric acid, and weak acids are acetic acid and nitric acid. Similarly, examples of strong bases are sodium hydroxide and potassium hydroxide, and weak bases are ammonium hydroxide. Now, third point I have written is alkalis. Alkalis are the bases which are soluble in water. They are called alkalis. Next is dilution of acids. On the basis of amount of water present in any acid or base, they can be categorized as concentrated or dilute. Any acid is concentrated if it has less amount of water, and it is dilute if it has more amount of water. Now, a very important question from exam point of view: while diluting an acid, why is it always recommended that the acid should be added to water and not water to the acid? The answer written here is dilution of concentrated acid is always an exothermic process. If water is added to a concentrated acid, the heat generated may cause the mixture to splash out and cause burns. When the acid is added to water slowly with constant stirring, the mixture will not splash out. Do remember to learn this answer, very important. Next, we are going to discuss the differences between acids and bases. As you can see on the screen, differentiate between acids and bases is a very important question you always get in your exams. You have to learn this table as it is. As we have already discussed, acids are proton donors or electron acceptors, whereas bases are proton acceptors or electron pair donors. Acids are able to increase the H plus ion concentration in an aqueous solution, whereas bases are able to increase the OH minus ion concentration in an aqueous solution. Acids have a pH value less than 7. Bases always have a pH value higher than 7. Acids always turn blue litmus to red. Bases turn red litmus to blue. Acids react with bases to form salts in aqueous medium. Bases also react with acids to form salt in aqueous solution. Acids always taste sour, whereas bases taste bitter. Examples of acids, you can write here lemon, tamarind, yogurt, etc. Whereas the things in which base is present are soap, baking soda, milk of magnesia. Some common formulae for acids are HCl यानी hydrochloric acid, H2SO4 sulfuric acid. Similarly, for bases, some common formulae are sodium hydroxide NaOH, KOH is potassium hydroxide, etc. Now the next topic is how can we come to know which substance contains an acid or a base. For this we use indicators. Indicators are the substances used to distinguish between acids and bases. Indicators can be categorized as of three types. First one is natural indicators. These are the substances obtained from natural sources such as dyes, flowers, leaves, etc. in the plants. Second category is synthetic indicators. These are the compounds synthesized in a chemistry lab or industrially rather than compounds found in nature. For example, phenolphthalein. Third category is olfactory indicators. These are the substances whose odor or smell changes in acidic or a basic medium. For example, vanilla essence. But the problem here comes is that they only tell about the presence of an acid or a base. They don't tell about how strong an acid or a base is. For solving this problem, we use universal indicators. Universal indicators are a mixture of several indicators. They show different colors at different concentration of hydrogen ions in a solution. These indicators not only detect the nature of other chemicals but also determine their acidic or basic strength. A scale for measuring hydrogen ion concentration in a solution has been developed and it is called the pH scale as shown on the screen. The P in this pH stands for potence, in German meaning power. On the pH scale, we can measure pH generally from 0, that is very acidic, to 14, that is very alkaline. Higher the hydronium ion concentration, lower is the pH value. Now, important question, what role does pH play in our daily life? You have to write this answer in points. First point is pH in soil. Plants require a specific pH range for healthy growth. Second point is pH in our digestive system. Overeating causes more amount of acids released in the stomach that make pH to fall in excess and cause acidity. Then we need to intake some basics like ENO to neutralize that acidity. Third point is pH change also causes tooth decay. If the pH value of saliva in mouth falls beyond 5.5 due to the action of bacteria present in the mouth, tooth enamel starts decaying. Tooth enamel is made up of calcium phosphate. Fourth point is self-defense by plants and animals through chemical warfare. Bee sting leaves an acid which causes pain and irritation. Use of a mild base like baking soda on the stung area gives relief. Stinging hair of nettle leaves inject methanoic acid causing burning pain. So these are the effects of pH in our daily life. Next, we are going to discuss the reactions of acids and bases. First reaction is when acids react with metals. As we all know, metals are bases. So when acid reacts with metals, salt is formed and hydrogen gas is released. For example, as written here, sodium hydroxide reacts with zinc crystals to form sodium zincate and hydrogen gas is being released. The second reaction is when bases react with non-metal oxides, salt and water is formed. For example, calcium hydroxide reacts with carbon dioxide to form calcium carbonate and water is released. The third reaction is when metal oxides react with acids to form salt and water. An example is written here. Copper oxide reacts with hydrochloric acid to form copper chloride and water is formed as a byproduct. The last reaction is all metal carbonates and hydrogen carbonates react with acids to form salt, carbon dioxide and water. Now we will study what happens when an acid reacts with a base. The reaction of an acid with a base is a neutralization reaction as a result of which salt and water are produced. Neutralization reaction is an important topic from exam point of view, so you all must understand the definition of salts also. Salts are the byproducts of neutralization reaction between an acid and a base. Salts of a strong acid and a strong base are neutral with pH value of 7. On the other hand, salts of a strong acid and a weak base are acidic with pH value less than 7, and vice versa. That means those of a strong base with a weak acid are basic in nature with pH value more than 7. An important point to note here is that salts having the same positive or negative radicals are said to belong to a family. For example, NaCl and Na2SO4 belong to the family sodium. They are called sodium salts. Similarly, NaCl and KCl belong to the family of chloride salts. Now let us start with various types of salts. As we have known by now that the salt formed by the combination of hydrochloric acid and sodium hydroxide solution is called sodium chloride. This is the salt that we use in food. Its common name is common salt or table salt. The reaction for preparation of NaCl is written here, and the uses are that it is mostly used in cooking purposes and it is also used as a preservative in pickles. When electricity is passed through an aqueous solution of sodium chloride, which is called brine also, it decomposes to form sodium hydroxide. This process is called chlor-alkali. I am repeating, this process is called chlor-alkali process because of the products formed, that is chlor for chlorine and alkali for sodium hydroxide. Next salt we are going to start is bleaching powder. As you can see here, bleaching powder is called calcium oxychloride. Its formula is COCl2 and the reaction for its production is written here. The main uses are that it is used for bleaching cotton textiles. It is also used in the manufacture of chloroform. Next salt is baking soda. Its name is sodium hydrogen carbonate and the formula is NaHCO3. It is produced when aqueous solution of sodium chloride is passed with ammonium and carbon dioxide. Then ammonium chloride is formed as a byproduct. Baking soda is used in the manufacture of soda water. It is also used to remove acidity of stomach. Next salt is the washing soda. Its name is sodium carbonate decahydrate. And the formula is Na2CO3 10H2O. Here 10H2O refers to the water of crystallization. As we have noticed in the above reaction, sodium carbonate is obtained by heating baking soda. Recrystallization of sodium carbonate gives washing soda. It is also called a basic salt. Washing soda or sodium carbonate decahydrate is used in softening of hard water. Also, it is used in the manufacturing of sodium compounds such as borax. Sodium carbonate is also used as a cleaning agent for domestic purposes. Next is POP, that is plaster of Paris. It is obtained from a raw material which is called gypsum. Gypsum has two water molecules as water of crystallization in it. Its formula is CaSO4 2H2O. On heating gypsum at 373 Kelvin, it loses water molecules and become calcium sulfate hemihydrate. This is called plaster of Paris. The doctors use it for supporting fractured bones in right position. It is also used for making statues, models, toys, etc. As we have seen, a lot of salts contain water molecules with them. These water molecules are called water of crystallization. The water of crystallization means having a constant range of molecules existing in one unit of salt. Crystal salts with water of crystallization are recognized as hydrates. The different names of water of crystallization are crystallization water or water of hydration. Example, copper sulfate pentahydrate CuSO4 5H2O. Now, as we finish the chapter, it's quiz time. The 5 questions I am giving you to learn are: first is, why does distilled water not conduct electricity whereas rainwater does? Second question, why do acids not show acidic behavior in the absence of water? Third question, what is neutralization reaction? Question number 4, what are antacids? Question number 5, you have to define these terms. First one is pH and the second term is universal indicator. Hope you all like this video and this video is helpful for your revision. Do like, share and subscribe. Thanks for watching.